Hello students, welcome to all of you Shiksha 360. Today basically we have to cover the chapter number 4 networking system part 2. In this session we have to discuss regarding the topologies that are very important for the examination point of view, and definitely you will get one or two questions straightforwardly from that part in the examination. So now let's start discuss regarding that. So network topology. Wait a minute. Yes, let's start. What is network topology? That is a network topology. It is the arrangement. Clear network topology. It is the arrangement of a network, including its nodes and connecting lines. Clear. So, what is network topology? It is the arrangement of the network, including its nodes and connecting lines. There are two ways of defining the network geometry. Clear. So, what are the two ways of defining the network geometry? First one, that is the physical topology. Second one, that is the logical or signal topology. Clear. So, there are two ways of defining the network geometry. First one, that is the physical topology. Second one, that is the logical topology. Okay, so now let's discuss regarding that both one by one. What is the physical topology? The physical topology, that is actual network, it is to be shown there. Like whatever the design or whatever the physical outlook, similar type of the network is to be there. Okay. So in the physical topology and the logical topology. The physical topology of a network, it is the actual geometric layout of the workstation. Clear? That is the actual layout, geometric layout of the workstation. There are several common physical topologies as described below and as shown in the illustration. Clear? So there are several common physical topologies as shown below and as shown in the illustration. So what are the physical topologies? Like first one here, that is the bus topology here. This is the main cable. Along with that, all the network are to be attached here. Clear? All the systems are to be attached here. In the central hub, there is a main central hub. And with that, all our systems to be attached here. What is the benefit of that or loss? We have to also discuss clear what is the advantage, disadvantage of each. So here that is from the one central computer, all the other computers are to be connected here. Here now information goes from like this way, circular way, that is in the form of the ring. Next one, that is the mesh. In the case of the mesh, all computers are interconnected with each other and some are not. Clear? Like this one, it is connected with this one, this one, this one, this one. But this is not connected with all. Clear? This is connected with only two. Okay. Why I'm discuss this point? Because in the theory, we will also cover that point. Next one, that is the tree in the form of the tree. Clear? Like branches. Last one, that is the point to point. Clear? Last one, that is the point to point. Clear? So all these are the different types of the topology. So now let's discuss one by one all these topologies to be here. So the simplest topology, it is a permanent link between the two endpoints. Clear? Simplest like this one. Permanent link between the two endpoints. Switched point-to-point topologies are the basic model of conventional telephony. The value of a permanent point-to-point network is unimpeded communication between the two endpoints. So now we have to move towards the different topologies. First one, that is the bus network topology. So in the bus network topology, every workstation is connected to a main cable called the bus. Clear? Like this way. Here system, here system, here system, here system. So in the bus network topology, every workstation is connected to a main cable called the bus. Therefore, in effect, each workstation, clear? So therefore, in effect, each workstation is directly connected to every other workstation in the network. Okay. So therefore, in effect, each workstation is directly connected. Clear? Each workstation is directly connected to every other workstation in the network. So in the bus network topology, every workstation is connected to a main cable called the bus. So therefore, in effect, each workstation is directly connected to every other workstation in the network. So what are the advantages? That is easy to connect, clear, because there is a line goes on continuously and you can easily connect, clear. So it is easy to connect a computer or peripheral to a linear bus, and it requires less cable length than a star topology, clear. Simple line it is to be going on. You can connect as much computers as you want upon the capacity of that wire, clear. One main thing you have to remember that the capacity of the wire, rest there is nothing any problem in that. So these are the advantage, that is easy to connect to a computer or a peripheral to a linear bus. Second one, that is require less cable length than a star topology. Next one, that is what are the disadvantages of a linear bus topology, clear. These are the advantages. Next one, that is what are the disadvantages of a linear bus topology. First one, entire network shuts down here. Clear? Entire network shuts down if there is a break in the main cable. Clear? Like if this cable it is to break, so all the network it is to be shut down here. Terminators are required at both ends of the backbone cable. Difficult to identify the problem if the entire network is shut down. Fourth one, that is not meant to be used as a standalone solution in a large building. Clear? Not meant to be used as a standalone solution in a large building. So in the star network topology, there is a central computer or server to which all the other workstations are to be directly connected. Okay, so this is the bus topology. Now next one, that is the star. In the star, we have already discussed this one. All are to be centrally connected to one point. So in the star network topology, there is a central computer or server to which all the other workstations are directly connected. So here every workstation is indirectly connected to every other through the central computer. Clear? Through the central computer, everyone is to be connected with each other. What are the advantages? That is easiest to install and wire? Because central there is a computer, just you have to put the connection from that, and all other are to be connected. Okay, that basically that PC is to be connected with the central hub and technology, or we can say that it starts functioning. No disruption to the network when connecting or removing the devices. Easy to detect fault and to remove the parts. Clear? Like here, this is the central 1, 2, 3, 4, 5. If this PC is not working, so we can able to easily understand that there is a error between from this point to this point. Clear? Either in the wire or in any other way, because all other are functioned properly. So this is functioning properly. Clear? So easy to detect. If like this one in the bus topology, this one, this one, this one, this one. If there is an error in that, so it is very difficult to identify where it creates a problem. Clear? Where it creates a problem. Clear? Okay. Because if the error is there in any wire or wire not functioning properly, so all the systems should stop the work. Clear? Stop their work. These are the points you have to be take care also here properly. Now move to the advantages and disadvantages. So easy to install and wire, no disruption to the network when connecting or moving devices. Easy to detect the faults and to remove the parts. What are the disadvantages of a star topology? That is requires more cable length than a linear topology. If the hub switch or concentrator fails, clear, nodes attached are disabled. Clear, if the hub switch or concentrator fails, nodes attached are disabled. More expensive than the linear bus topology because of the cost of the hub switch. Clear? So it is more expensive than the linear bus topology because of the cost of the hub switch. So that is regarding the star network topology. Now move to the next one, that is the ring topology. Ring topology like this way. Okay, so in the form of the ring. So in the ring network topology, The workstations are connected in a closed loop configuration. Clear? So in the ring network topology, the workstations are connected in a closed loop configuration. Adjacent pairs of workstations are directly connected. Other pairs of workstations are indirectly connected. Clear? So adjacent pairs of workstations are directly connected, and the other pairs of workstations are indirectly connected. The data passing through one or more intermediate nodes. So if a token ring protocol it is used in a star or in topology, the signal travels only in the one direction, carrying by so-called token from node to node. Clear? That is token ring protocol. That is, in that case, it is the basically signal travels only in a single direction. Clear? If the token ring protocol it is to be used either in a ring or a star topology. So now let's discuss what are the advantages of a ring topology. Clear? In the ring topology also, all systems are interconnected with each other. This type of network topology it is very organized. Each node gets to send the data when it receives an empty token. Clear? Each node gets to send the data when it receives an empty token. So this helps to reduce the chances of the collision. Clear? This helps to reduce the chances of the collision. Also in the ring topology, all the traffic flows only in the one direction at a very high speed. Okay. Also in the ring topology, all the traffic flows only in the one direction at a very high speed. Clear? Even when the load on the network increases, its performance is better than that of the bus topology. There is no need for the network server to control the connectivity between the workstation. Each computer has equal access to the resources. Each computer has equal access to the resources. These are the advantages of the ring topology, and definitely you will get even 5 mark question on the topologies in the examination. Now, what are the disadvantages? Each packet of data must pass through the computers. Clear? Each packet of data must pass through all the computers between the source and the destination. This makes it slower than the star topology. Clear? In the star topology, from the center, the data is to transfer to all the points. Here, each packet of data must pass through the computers between the source and the destination. So this makes it slower than the star topology. If one network or port goes down, the entire network gets affected. Clear? If one workstation or port goes down, the entire network gets affected. Network is highly dependent on the wire which connects the different components. Okay. That is, network is highly dependent on the wire which connects the different components. MAUs and network cards are expensive as compared to the internet cards, and this is one of the disadvantages also, that is MAU and network cards are expensive as compared to the internet cards and the hubs. So these are some of the advantages and the disadvantages of the ring topology. And I think all of you are able to understand regarding all the points. Now we have to move to the next one. Mesh network topology. Clear? In the mesh network topology, each computer is attached to the other one. Clear? And some are not. That is partially mesh and completely mesh. Clear? Fully mesh. So the mesh network topology employs either of the two schemes, that is full mesh and partial mesh. So in the full mesh topology, each workstation is connected directly to each of the others. In the partial mesh topology, some workstations are connected to all the others, and some are connected to only those nodes with which they want to exchange the most data. Okay. So the mesh network topology employs either of the two schemes called the full mesh and the partial mesh. In the full mesh topology, each workstation is connected directly to each of the others. In the partial mesh topology, some workstations are connected to all the others and some are connected. Clear? In the partial mesh topology, some workstations are connected to all the others and some are connected only to those other nodes with which they exchange the most data. Clear? Basically, with which they exchange the most data. So what are the advantages of the mesh topology? That is, a broken node would not distract the transmission of the data in a mesh network. Clear? A broken node would not distract the transmission of the data in a mesh network. Second one, additional devices in a mesh topology will not affect its network connection. Clear. Additional devices in a mesh topology will not affect its network connection. So advantage first one, that is a broken node would not distract the transmission of the data in a mesh network. Additional devices in a mesh technology will not affect its network connection. A mesh topology can handle the high amount mesh topology can handle the high amount of network traffic since every additional device, clear, since every additional device into the network is considered as the node, clear, consider as the node here, clear, or that will be considered for providing the network to be here. What are the disadvantages? Clear. Kindly understand all these points. I will. If there is any broken node in the mesh topology, so there will be not an issue. Clear, because all are interconnected with each other. Additional devices will in a mesh technology will not affect its network connection. And next one, that is high amount of the network traffic. Since several additional device into the network is considered to be as a node. Now, next one, that is what are the disadvantages of the mesh topology? First one, that is maintaining mesh networks can be very hard to manage. Second one, due to the fact that the building this topology requires a lot of devices, so it will require a lot of capital to invest in. Clear? So maintaining mesh networks can be very hard to manage. Second one, that is due to the fact that building this topology requires a lot of devices. So it will require a lot of capital to invest in. Clear? So it will require a lot of capital to invest in there. Okay, so these are some of the advantages and disadvantages of the mesh topology. Any other point if you want to understand here or if you want to know, so please tell fast if anyone doubt in your mind here. Now move to the next one, that is the last one, that is the tree topology. So the tree network topology uses two or more star networks connected together. Okay, star networks. Kindly remember that the tree topology uses two or more star networks connected together. Because these are the star networks. Show where you the example, this one. This is the star. This is another star. So the tree network topology uses two or more star networks connected together. The central computer of the star network are connected to a main bus. The tree network, it is a bus network of the star networks. Clear? So basically the tree network, it consists of both the bus network and the star network. So what are the advantages of the tree topology? First one, that is point-to-point writing for the individual segment. Second, supported by the several hardware and the software vendors. Clear? First point, that is point-to-point for writing for the individual segments. Clear? Point-to-point wiring for the individual segments. Second one, that is it can be supported by the several hardware and software vendors. Clear? Further, it is to be supported by the several hardware and the software vendors. What are the disadvantages of a tree topology? First one, that is overall length of each segment is limited by the type of cabling used. Clear? So overall length of each segment. Clear? Overall length of the each segment, it is limited by the type of the cabling used. Second one, if the backbone line breaks, so the entire segment goes down. Like if the this one lines break, from here the everything it is to going to be started. So everything it is to be stopped now. More difficult to configure and wire than the other topologies. Clear? More difficult to configure and wire than the other topologies. So every network topology has its own up and down. So basically it depends upon your requirement, what type of the network you want. So it will only matter on how you structure it very well. And if the nature on your business requires a bigger network system. Clear? So every network topology has its up and down. It will only matter on how you structure it very well. And if the nature of your business requires a bigger network system, It is important to keep learning about what you need in your business or place to be able clear. So it is important to keep learning about what you need in your business or place to be able to come up with an effective system wherein your investment would not go to waste and your revenue will give up you excellent output. Clear? So it is important to keep learning about what you need in your business or place to be able to come up with an effective system. Clear? Would be able to come up with an effective system where in your investment would not go to waste and your revenue will give you the excellent output. Clear? And your revenue basically will give you the excellent output. Okay, so this is regarding the different types of the topologies. Now, next one, that is for all the sessions regarding the CAP, you can join our elective IT batch. So next one, that is we have physical topology. This one, next one, that is the logical or signal topology. So logical or signal topology basically refers to the nature of path the signal follows from node to node. Clear? It basically refers to the nature of the path the signal follows from node to node. In many instances, the logical topology, it is the same as the physical topology. Clear? In many instances or in most of the cases, the logical topology, it is to be similar as the physical topology. But this is also not the case. Clear? Not always it will be same here. So where it will be different, creates the difference. What is that? So, but it is not always the case. For example, some networks are physically laid down in a star configuration, but they operate. Clear? Some networks are physically laid out in a star configuration, but they operate logically as a bus or ring networks. Clear? So it means that whatever the represent, it not depends totally that they will work according to that or not. Clear? So that will not totally, we can say that they will work according to that or not. Clear? So that is a logical topology. We can say that in simple language, from the representation, we are not able to understand whether they will work like that or not. So now after that, we have to move to the next point. That is the IP addressing. Clear? We will also brief in this session regarding the IP addressing. So what is that? Because this is also one of the important topic, that is the IP address. Very, very important. So an IP address or the internet protocol. IP stands for the internet So an internet protocol address, it is a unique identifier for a node or host connection on an IP network. Clear? So it is a unique identifier for a node or host connection on an IP network. Clear? Each computer has its own IP. Each PC has. So an IP is a 32-bit binary number. Clear? An IP, it is a 32-bit binary number, usually represented as four decimal values. Clear? IPv4. Internet protocol. Here it is a 4-byte or 32-bit binary number. On the other side, the size of an address in IPv6 is 128 bits. Clear? 128 bits IPv6 with the 6 decimal points. IPv6 is discussed in detail. Basically, each addressing 8 bits in the range of 0 to 255. 8 basically octet. All are to be separated by the decimal points. This is known as the dotted decimal notation. Clear? So how it is to be notation? What is the notation of that? That is to be dotted decimal notation to be here. That is IP addressing. Either it is to be 32-bit or 128-bit. So now let's discuss some few points regarding that. Like here, there is one example. Example here, that is 140 192.169.220.200. Clear? So this is an IPv4 address. Clear? This is an IP address to be here. So it is sometimes useful to view the values in their binary form. Clear? It is sometimes useful to view the value. So 140, how they will convert it? Just simple. Divide it by 270, 235. So whatever basically will the remainder basically 0. 217, it will be 1, it will be 0. Clear? So in this way, you are just able to understand that. Clear? How it will be totally goes on. Clear? How it will be totally goes on to be here. So in this way, you are able to understand. If you want further, I will explain here. 2 8 just 16, remainder 1, 2 4 0. Basically up to this much point. 2 2 0. 2 1s are 2 0, last 1. Okay, so this will be represented as from bottom 1 3 times 0 double 1 double 0. Okay, so this is the way to represent. Okay, so how we can convert into the binary? I think it is very easy. From the school time we are able to understand how we can convert into the binary. So 140.179.220.1. Here they are showing that this is the decimal. How we have to convert into the binary? I think easily you can able to understand. Now, if anyone has any doubt, any query regarding that, you can ask regarding how we have converted into the binary, digital to binary, or decimal to binary. So every IP address consists of two parts. Very, very important. Every IP address, like this one, it is the IP address. It will consist of two parts. This is the one part. This is the another. So one part identifying the network. This will identify the network here, and the other part identifying the node to be here. The class of the address and the subnet mask determine which part belong to the network address and which part belongs to the node address. Clear? So generally this will be the clear. The class of the address, how we can identify the address, I will cover. The class of the address and the subnet mask determine which part belongs to the network address and which part belongs to the node address. So there are currently two versions of the internet protocol, IPv4 and new version, that is 6. IPv6, it is an evolutionary upgrade to the internet protocol. IPv6 will coexist with the older IPv4 some of the sometime. IPv4, Internet Protocol version 4, it is the most widely deployed internet protocol used to connect the device to the internet. Further, it uses a 32-bit address scheme, allowing the total of how many addresses, that is 2 raised to power 32. This is the maximum address they can formulate, that is just over 4 billion addresses. With the growth of the internet, it is expected that the number of unused IPv4 will eventually run out, because every device, including the computer, software, smartphones, and game consoles that connects to the internet requires an address. Clear? For connecting to the internet, every system basically will require an address. So a new internet addressing system, Internet Protocol version IPv6, it is being deployed to fulfill the needs for both internet addresses. So now we have to discuss in detail regarding that. So here, now we can see how the class determines by default which part of the IP address belongs to the network and which part belongs to the node. So here, like, it depends. If it is the class A, so only first part belongs to the network and rest parts belong to the node. If it is a class B, first two parts belong to the network. So capital N basically belongs to the network and small n belongs to the node. If it is class C, so first three define the network, last one the node. Clear? So here either it will be the network, only this one will be the network, or AB both the network, or ABC both the network. Clear? So it depends upon case to case. I will here take on the example of a class B. So now you are able to understand how the classes basically will make the difference. So this is the example. So address class of IPv4. So there are 5 different address classes. You can determine which class any IP address it is in by examining the first 4 bits of the IP address. Okay, first 4 bits. How we can that is class A. Class A, that is first 4 bits. 1.0.0.1 to up to 126.255.255.254. Clear? So if it is from 1 to 126, first bit. So that is large network with many devices. From class B, that is 128 to 191. Then it is to be class or medium sized network. 192 to 223. It is to be small network, that is fewer than 256 devices. 224 to 239, that is reserved for the multicast group. Last 240 to 255, that is it is reserved for research and development. Clear? That is to be reserved for the research and development. Just you have to be remember up to how much we have to go now. Clear? Up to how much we have to go now. From 1 to 126, large network. 128 to 191, that is medium. 191 to 223, it is to be small network. 224 to 239, that is reserved for the multicast group. And last one here, that is the 240 to 255, it is to be reserved for the research and development. We reserved for the research and development to be here. So addressing beginning with this one, 2 or 127 decimal are reserved for the loopback and for the internal testing on a local machine. So you can test this, that you should always be able to think 127.0.0.1, which points to yourself. Class D address reserved for the multicast group that are reserved for the multicast. Class E addresses are reserved for the future use. And they should not be used for the host addresses. Basically, first 3 are to be used for the host addresses. Okay, so anyone has any doubt, any query up to this much point regarding the classes in the IP address? Okay, and definitely you will get from the topology or from the IP address one question directly you will find in your examination. Very easy type of the question. Just you have to remember all these points. So in the example, 140.179.220.200. So it is which type of the class in the examination if they'll ask. So it is starting with 140, so it is a class B address. So we default the network part of the address, it is to be the network address, and it is defined by the first 2 octets. That is, and the node part it is to by the last 2 octets. Clear? So in order to specify the network address for a given address, IP address, the node section it is to be set to all 0. So in our example 140.179.0.0, specify the network address. Okay, that is for 140.179.220.22.200. So when the node section is set to all 1, so it specifies a broadcast that it is sent to all the hosts on the network. Specifies the example like we can say that. So note this is true regardless of the length of the node section. Okay. So I think you are now just you are able to understand from the IP address we are able to identify basically from which class it is to belong. Either class A, class B, class. Okay. And in the examination you will get questions from these points definitely. Kindly remember all these points. Definitely you will get questions from these points. If anyone has any doubt, any query up to this much point, please ask. MCQs will be shared later to that in the group today, here from that chapter. Kindly practice all the MCQs and slides will be provided in the evening. So thanks to all of you for joining this discussion. Hope you are able to understand regarding all the basic points regarding. Thanks to all of you.